Hey there, science enthusiasts. Today we're diving into one of the most mind-blowing concepts in astrophysics, Hubble's inflating bubble theory, and how it explains the expansion of our universe. So, let's start with the basics. Imagine the universe as a gigantic balloon. As you blow air into this balloon, it expands. Now picture galaxies as tiny dots on the surface of this balloon. As the balloon inflates, these dots move away from each other. That's essentially what's happening with our universe. Hubble's observations in the 1920s led to the discovery that galaxies are moving away from us, and the farther they are, the faster they're receding. This gave rise to the concept of an expanding universe. But what's causing this expansion? Enter the inflating bubble theory. According to this theory, the universe's expansion is like an inflating bubble with no center. Instead, space itself is stretching, pushing galaxies apart. This creates a sort of vacuum or low-density region in the middle of the bubble. Now you might wonder, does this expanding bubble create a central energy mass, similar to how the moon affects Earth's oceans, causing high and low tides? The answer is no. The universe doesn't have a center like an ocean does. The expansion is happening everywhere at once, making every point in the universe appear as the center from its own perspective. But there's more to it. Some theories suggest that the cold vacuum of space forms an invisible, growing anomaly at the heart of this inflating bubble. This vacuum isn't empty, it's filled with dark energy, a mysterious force that's driving the acceleration of the universe's expansion. Think of it like this. Electricity doesn't flow through a wire itself, but acts as an invisible force around it. Similarly, dark energy isn't something we can see or touch, but it exerts a powerful force on the universe's fabric. So, while the moon's gravitational pull creates tidal waves on Earth, dark energy generates an enormous tidal wave in the fabric of space-time, propelling galaxies apart. Both phenomena involve forces acting invisibly, yet profoundly, on their respective environments. In essence, Hubble's inflating bubble theory and the concept of dark energy provide a fascinating glimpse into the mechanics of our ever-expanding universe. It's a mind-bending journey that reminds us how much there is still to learn about the cosmos. Thanks for tuning in. Don't forget to like, subscribe, and hit the bell icon for more cosmic explorations. Until next time, keep wondering and keep exploring the wonders of the universe.
This photograph, even though I haven't been able to put any animation on it, represents the Hubble bubble. Even though Erwin Hubble calls it he calls it a balloon, inflating balloon. This is somewhat what it looks like. All these galaxies around this sphere in the center are outside the sphere. Relativity, new information of people updating Einstein's theory say that all the galaxies and everything are inside this bubble. And since the bubble is expanding, there's more room inside the bubble. The only thing that contradicts is pressure and the manipulation of energies from the galaxies that would be in it that change the physical form of a vacuum. What is a vacuum? Absent of matter, and in that case, absent of energy. In this photograph, with the galaxies outside this expansion, it shows how they're being pushed apart. The galaxies are being pushed away from each other as this thing inflates. It's somewhat invisible inside because it's the energy that this thing, this sphere, invisible sphere, at the center of our universe is causing expansion, is causing motion because of its momentum at a constant rate, which is faster than light. It's that much energy that this sphere has that it is accelerating a pathway for our galaxies. As this thing expands, it moves the galaxies, creating a movement in our universe. Without it, our galaxy would be just sitting there, and probably the universe would collapse because there's nothing holding them back from collapsing in on each other. So this sphere, invisible sphere, is created from the energy of all the galaxies. I don't know if it was, you would call it created from them, but if you look at the moon, high tide and low tide, its effect on Earth's ocean, think of how all the galaxies having toll on this midfield invisible anomaly. The energy we see comes from the moon to our oceans, predicting higher and low tides. We don't see it here either. You don't see that energy, but we can see its effect. The universe is expanding. How this was formed from the beginning is not beyond me. We look at the elements. Before there were galaxies in empty space, what existed? Cold. Cold is an element that changes form into water. Energy causes an effect of raising the tide of that invisible element. Or actually, it'd be invisible because it would be transparent. So when we look at Isaac Newton's theory on how the planets stay in their position and orbit and rotate, it's that energy that forms this anomaly of the photograph I'm showing you here now. Without it, the universe would collapse. This is a theory that I've developed. I put out a new book. It's called Expanse Vacuum Gravity. It goes beyond Hubble's observations. It reforms the idea of a subtle universe, as relativity predicts, and it shows a consistency, whatever, of a faster than light force. If we go back in Earth science, we discover that in physics, in the evolution of energy, motors, generators, etc., they discovered that And it was formatted from this that it takes 2 pounds of energy to move a 1 pound mass. In other words, if you only have 1 pound of energy trying to push a 1 pound mass, it's not going to move. That's Einstein's relativity, a subtle universe. When you have momentum, you need 2 pounds of energy for that 1 pound mass. Now, when we convert that to the universe, how much energy do we need to push on all the galaxies relative to that theory that I've just mentioned? You need twice as much energy. So my predictions that the universe is the force of this anomaly is 450,000 miles a second relative to squared energy. That much energy it takes to put the universe in motion and keep it in motion because this is at a constant. And it's expanding the area between the galaxies in uniform motion. In other words, all the galaxies are there because that's the accepted position using Isaac Newton's theory on position and gravity of all the planets in space. So something could be born within that, which would affect the other galaxies, a newborn planet, sun, whatever, and change it just a little. The distance between the galaxies is enormous. So a newborn galaxy would be, it's logical, you know. But when we look at all these theories about newborn planets and stars and everything, they're all inside a galaxy that is already there. It's motion that keeps these galaxies alive, let's say. Without them, just think of it, it would be, everything would burn up or freeze. Those are the two main elements of our space. How much heat there is, I think it's 4K, and how cold it can get. There's more cold in the universe than there is heat or suns or warmth from all the other matter that exists. This is an explanation of my new expanse theory. It takes twice as much energy. That means the force that causes to put our universe in motion is twice as much that Einstein predicts to be the speed of light. In Einstein's theory, 1 pound of energy of energy will advocate for 1 pound of mass. But that's not how it works. That means there would be no movement in our universe, or it would collapse. Just think about it, it would collapse because there's nothing to keep it from collapsing. I hope you like my videos. I have a new book coming out. It's called EVG Expanse Vacuum Gravity, putting the universe in motion. Thank you. My books are on Amazon. Thank you.